So here's a video to help with teaching radicals. So at the top it tells you what kind of form it's going to be in, radical or exponential. So for exponential, you're converting it and you're going to teach them inside, divide, outside. So you're saying b has an exponent of 1 on the outside. Since it's a square root, it's 2. So your base is b, inside, divide, outside. Exponent is 1, outside is 3. So inside, divide, outside. So exponential form is your base and your exponent is going to be inside, divide, outside. Now when you're rewriting it in radical form, you want to identify the exponent as inside, divide, outside. So your radical, on the outside it's 4, x is your base, and the exponent is 1. Same thing with y. This is the outside, this is the inside, radical 2. Y has an exponent of 1. Or you want to get them to understand it's just radical y. We don't write the 2. Alright, when you're simplifying them, again, these can be put into the calculator like numbers, but you get them to understand how to simplify perfect roots by saying to remember inside, divide, outside is basically what we're doing. So you take your base x and you take inside, divide, outside, so x squared. Number 2, you take the outside, which is 2, inside, divide, outside, y squared. 6, same thing. When it divides evenly, or it's divisible by itself, it's just a 1. Same thing with 4. When you get down to 6, 7, and 8, you want to do it for each term. So same rule, you go to 6 and you say your base is 2, inside, divide, outside. Your base is x, inside, divide, outside. So 2, exponent 1, x, exponent 8, or you just say 2. All right, so now let's get down to the bottom where they're not perfect. So when they're not perfect, you tell them to break it down. So when they're not perfect, for example, on number 9, you're gonna look at 9 and say the outside is 2. You can't take inside, divide, outside. You're gonna get a fraction or a decimal. So you need to break this 3 down and go down a power. So you still have your radical. 3 is gonna go down, 3 exponent 3 is gonna go down 3 squared times 3 to the first. It still applies the same rule. In the end, when you add the exponents, it should be 3. 5, you can't divide that by 2. So again, you break down x to the 4th, x to the 1st. You go down just 1 power. So from here is what you want to tell your kids is anything to the 1st power stays under. Anything divisible by 2 will come out of your radical. And you do the same rule, inside, divide, outside. So 3, inside, divide, outside, x, inside, divide, outside, and I still have everything under the radical 3 times x. So from there you simplify. 3, inside, divide, outside is just 3, x squared, radical 3x. And you can tell them to check their answer to make sure it comes out for your numbers. So if you wanted to, on the calculator, they can put numbers in the calculator. So you're gonna tell them, if you wanna take the square root of 3 cubed, oops, that's 5.19665. Just match the numbers, 3 square root 3, and make sure that they're following on that. They can do that if you feel like they're gonna make a mistake. So that's your breaking down. If you don't have to break it down, don't break it down. So that's day 1 of notes. For day 2 of notes, we talked about simplifying radicals using the calculator this time. So when we use the calculator, you're going to rewrite the factors with exponents divisible by the index. So that's where you're going to use a calculator. On a calculator page, you're going to use menu 2, 3. 2 for number, 3 for factor. Menu number 2 for number 3 for the word factor. And that's what you want them to tell them to look for. Menu 2, 3, factor. So on the calculator page, there's 2 options. When you do menu 2 for number 3 to factor, you can put in the number, or, so first example is 50. Or if they're gonna forget the steps, they can literally type the word factor into the calculator and get the answer the same way. But either way, they're gonna need the calculator for this assignment. So, all right, so they're gonna put only what's under the radical. Stress, they're not putting the radical. So they're factoring 50, and when they do that, they get 2 times 5 squared. And this is where you use that rule, inside divide outside. So the outside is 2, exponent is 1. Anything to the first power stays under. If it's divisible by 2, bring it out. So 5 squared divided by 2, inside divide outside, radical 2. You simplify to 5 radical 2. Again, tell them to make sure they check in the calculator. Square root of 50 square root of 50 is 7.07, and then you do 5 square root 2, it's the exact same thing. So they can always check in the calculator. Let's go over a couple of examples where you have to break it down. And let's look at something like square root of 120. So square root of 120, you put in the calculator, menu 2, 3, 120, menu 2, 3, 120, and you get 2 to the third times 3 times 5. So you rewrite radical 2 to the third times 3 times 5, and you tell them anything to the first power stays under, anything to the first power stays under. When you look at this, you ask yourself, do I need to break this down, or can I leave it the way it is and divide? When I take 3 inside divide outside, it doesn't divide evenly, so I break it down. 2 squared times 1 times 3 times 5. Now you tell them again, anything to the first power stays under, anything divisible by, any exponent divisible by 2 comes out. So 2 exponent 2 divide 2. 2 times 3 times 5 will stay under the radical, and then you simplify. 2 exponent 2 times 2 is 2, and then 2 times 3, 6, 6 times 5 is 30. So square root 30. So again, numbers they can put in their calculator, but you teach them that method so they apply it to variables. So you would apply the same rule to something like number 4. Let's do 4. Square root of 192 times x to the third. So you put in your menu 2, 3 to factor 192. Tell them you can't put variables in there. So you get 2 to the 6th power times 3. So this is going to be 2 to the 6th power times 3 times, and you ask them, can I leave x to the third the same, or do I need to break it down? Break it down because it's not divisible by the outside. So it's x squared times x. All of this is still under the radical, and then you go through that process and say x to the 6th, or 2 to the 6th power. Is that exponent divisible? Yes. So it's coming out of the radical. 3 to the 1st power. Anything to the 1st power stays under. X squared. It's divisible, so it's coming out. X to the 1st power. Anything to the 1st power stays under. So 2 to the 6th power divided by 2 x to the second power divided by 2. Radical 3x stays under. So 2 to the 6 divided by 2 is 2 to the third, which they need to simplify to 8. X, first power, radical 3x. Same thing, they can take 8 radical 3 and check if it's the same thing as radical 192. All right, when you have a number in front, you're multiplying the number on the outside, very similar to the exponent rule where they had something on the outside of the parentheses, they didn't distribute, and you multiply the number on the outside. So here, you're gonna tell them to bring down that 2 the whole time. Whatever they bring out, they're multiplying with it. So here, you're gonna leave the 2 on the outside. Whether you do it over here, the 2 on the outside stays radical, and you're only putting factor 40 in the calculator. So you put it in the calculator, menu 2, 3, 40, you get 2 to the third times 5. So under the radical, it's 2 to the third times 5. You ask them, can you break it, or do you have to break it down? Yes. Exponent doesn't divide evenly, so you break this down to 2 squared times 1 times 5. 2's on the outside again. Now you're gonna say anything to the first power stays under, anything to the first power stays under. So you know 2 times 5 is gonna stay under the radical, and then you're gonna bring out this 2 squared and divide inside, divide outside. So you're gonna take that first 2 and bring it down. You're gonna take the other 2 and divide inside, divide outside. They can put this whole piece in their calculator, and that's what I've been telling them for exponent rules. Or you can just simplify and say this is 2 times 2, exponent 1, radical 2 times 5. Simplify from here. 2 times 2 is 4, radical 10. They simplify both. Again, they can type both of these into the calculator and make sure they match. And then apply that same concept to something like 3, 4, 5, and 6, where they have a variable. If you guys still have questions, come and see me. But if you need another example, I can do, let me see. We can do 6. Here you put in the calculator, only factor the number 18. And you get 2 times 3 squared, factor, menu 2, 3, 18, 2 times 3 squared. So this is 2 times 3 squared. X, you tell them you have to break it down, go down 1 power. Y, you have to break it down, go down 1 power. And in the end, they need to make sure the exponents add up to the original problem. So all of this is still under the radical. You ask them which ones are going to stay under. Anything to the first power will stay under the radical. Anything to the first power will stay under the radical. So under your radical, you should have 2xy. 2xy. And what I sometimes tell them is once you identify what stays under, cross it out so you're not writing it again. Get rid of it because we already know where it's going. From here, focus on what's left over. You have 3 squared and you're gonna take it out, but you need to divide inside, divide outside. So 3 inside, divide outside. X is gonna come out as well. X, inside, divide outside. Y, same thing, inside, divide outside, and simplify from here. So this becomes 3, this becomes x squared, this becomes y, radical 2xy. Again, if you need more help, you can come see any of the other teachers that have taught it before, but that's basically what you're going to use for day 1 and day 2.